Welcome to the Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll be answering the question, how do I solve a quadratic equation that looks factored, but it doesn't equal 0? Well, we start out by multiplying those factors back out that looked factored to begin with on one side of the equation. Then we proceed through the process just like you're solving any other quadratic equation. We rearrange the terms into standard form, which is ax squared plus bx plus c equals 0. We solve by factoring and then applying the zero product principle. And finally, after we find those solutions, we check to make sure that they are actually solutions by substituting into the original equation. Let's take a look at an example. All right, so you see I have here x minus 2 times x plus 3 equals 6. And this is a quadratic equation because you notice if I start distributing each term in the first set of parentheses to each term in the second set of parentheses, that first distribution that I do when I multiply x by x, I get x squared. So this is a quadratic equation. X times 3 is positive 3x. Coming back to the negative 2 to distribute, I get negative 2 times x, which is negative 2x. And negative 2 times 3, which is negative 6. And that equals 6. Well, you know we can't apply a zero product principle unless we are equal to 0. So in this next step, we're going to combine the like terms 3x and negative 2x and subtract 6 from both sides of the equation. And that gives us x squared plus x minus 12 equals 0. Now we have our quadratic equation in standard form. Ax squared plus bx plus c equals 0. So we're ready for that next step of the process, which is to factor the polynomial side of the equation. And for this particular type of trinomial, I simply have to ask myself, what are the factors of negative 12 that add to make 1? Now, if you're curious as to where that 1 came from, remember it's b, and there's an understood 1 being multiplied with the x term there. So, coming back to our question at hand, the factors of negative 12 that add to make 1 are 4 and negative 3. When I multiply positive 4 and negative 3, I get negative 12. And when I combine them, I get positive 1. So the left-hand side of that equation factors as x plus 4 times x minus 3 equals 0. Now I've got it into the form of factors being multiplied to equal 0. So using my zero product principle, I know that if I'm multiplying together to make 0, that I had to be multiplying with 0. So applying that principle, we set up the equations of each of our factors potentially being equal to 0 here. And solving each of these, for the first one, I subtract 4 from both sides, and I'm left with x is negative 4. And then for my second equation, I add 3 to both sides to get that x is equal to 3. So there are our two potential solutions, and now we need to check both of them separately. So we'll start by checking x is negative 4. And don't forget, when you go to check your equation, you want to plug into the original equation. So we have x minus 2 times x plus 3 equaling 6. And we are trying our potential solution of negative 4. Okay, so when I come back to do the math here, -4 and -2 combine to make -6. And -4 and 3 combine to make -1. And sure enough, when I multiply -6 and -1, I get +6 equaling to +6. Meaning that -4 is actually a solution to our quadratic equation. Now let's check x being 3. So once again, we start back with our original equation, x minus 2 times x plus 3 equaling 6. And this time I plug in our potential solution of 3. 3 minus 2 gives 1. And I multiply that by 3 plus 3, which is 6. And sure enough, I get 6 equals 6, which is our true statement that we're looking for. To confirm that we have two solutions to this quadratic equation, -4 and 3. Also like to remind you that those can be written as a set, -4, 3. And we have the quadratic equation solved. So I hope that this has been helpful for you with knowing how to solve a quadratic equation that might look a little bit funny to begin with. Remember, you always want to make sure that you're equaling 0. If you don't equal 0, there's no way to apply the zero product principle. So if you have any other questions about factoring and using the zero product principle to solve a quadratic equation, make sure to contact your Highlands instructor. Thank you.